All right, we'll hand it over to Pierre to pivot to the Pi system.
Thanks, Tim, and thanks, Mike. Great presentation. So, hey guys, it's Pierre again. I'm going to be spending the next 30 minutes doing a deep dive into the Pi system, as well as the new Pi integration methods to OMI and the AVEVA historian that I mentioned earlier. We also had AVEVA reports slated for this time slot initially, but Brian was able to cover all of the new features. So instead, I'm going to be spending the whole time slot here discussing the Pi system. So I'm going to start with a PowerPoint presentation, and then I'll do a demo of the Pi system. Can everyone see my screen right now?
We can.
Awesome. Thank you, Tim. So let's start by revisiting briefly what the Pi system is, talking about the value of it and what it actually does. So let's start with this. Managing operations data is a complicated process, as many of you know. Your plant floor can contain, dozens, if not hundreds or thousands of important pieces of machinery that are crucial to your process. We're lucky that, we live in a time that technological advances in industrial automation allow us to, easily communicate to these devices and gather insightful data from them. But a common issue is that there's a plethora of data sources with specific proprietary communication protocols and data types and data flows, which, this can lead to pretty complex data streams, as you see, on this diagram here. So the process of getting the data from the different data sources on the left to the appropriate consumers on the right is typically fairly complicated and difficult to track, especially as you scale up. It becomes increasingly difficult to manage and expand. So that's where Pi comes in. Pi seeks to provide order to the chaos that is operations data. So what is Pi? Well, like I mentioned before, Pi is an enterprise data management platform. Again, I want to stress that it is not a SCADA platform, right? It's a software ecosystem that acts as a powerful and robust historian, but it is not SCADA. It's not, you don't write, you don't control, you only monitor with it. So as we saw earlier, this diagram kind of illustrates the role that Pi system plays. It all starts with the collection of operations data from, as I said, there's a plethora of data sources on your plant floor, right? So this can include SCADA platforms like System Platform, for example, or Edge, PLCs. You also support SQL databases, manual data entry, and cloud systems, so on and so forth. The second step of the process is the storing and enhancing of the data using the historian capabilities of Pi, which we will look at later in this presentation. And finally, the last component kind of to the workflow is delivering this organized data to the right data consumers. So let's talk about the architecture of the Pi ecosystem. Generally speaking, you have kind of three broad constituents to a holistic Pi system. You have your Pi Edge, your Pi Core, and your Pi Cloud, which you can see in the middle of the diagram here. So these three units work together to provide all the necessary components that you need to collect field data, historize it, store it, organize it, like we said, analyze it, and deliver it to the right consumers. This helps the Pi system address, a variety of IoT use cases that we have, kind of in our industry. So the first component is Pi Edge, which is the Pi Edge data store on the left side there. So the Pi Edge data store allows you to tap into data from remote assets that are beyond your control or your SCADA network, right? So these are data sources that are generally difficult or expensive to connect to, but the Pi Edge data store simplifies that process through the use of the Pi Edge adapters. So you can use these Pi system interfaces and adapters to easily share that aggregated data that you aggregate at the Edge data store to the Pi core. So you can collect data from remote assets that aren't on your plant floor and then share it with your Pi server, the Pi core. And that's the second major component, which is, the Pi core, also known as the AVEVA Pi server, depending on who you ask. This is where your on-premise Pi components are situated, which includes, the bread and butter Pi server, which is the historian that we talked about. So the Pi server is a secure and robust system that's designed to collect huge volumes of operational data that comes from your plant, like SCADA, DCS, PLCs, like we talked about, and also on-prem sources like relational SQL databases or even manual data entry. Really, you have all sorts of data sources that are supported that are meant to aggregate into the Pi server. And like I mentioned before, that can include data collected from the Pi Edge data store. And last but not least, we have the Pi Cloud, which it was formerly known as OSI Soft Cloud Services. And with the acquisition and the rebranding, it's now part of AVEVA Data Hub. And this is essentially an edge to cloud data management platform. The goal being that you can use the cloud to share your data more easily without needing to use your on-premise solution. So you're agnostic to, on-premise Pi components. And this really opens the gates to API and other cloud service integrations. So you can leverage the Pi Core and the Pi Cloud in tandem to consume all this data using visualization products like Pi Vision and Pi Data Link. And those are the visualization clients that I'll be demoing later in this time slot. So not all of these major components are required for a successful Pi system. So you don't need the Pi Edge data store, for example, if you don't have any remote assets, right? You might only have data coming from your plant floor, right? In which case you only need your Pi Core. But really the point of this slide is to demonstrate to you guys how the Pi ecosystem works in unison to collect and provide the data to a broad variety of users, as we'll see in this demo. So when you're building out your Pi ecosystem, there's 3 layers to the workflow. Data collection is where it all starts. One of the main strengths of the Pi system is that it can connect to any source of operations data. So to throw out some numbers, we have over 400 interfaces, connectors, and adapters, over 400, which allow you to natively read from over 225 different industrial systems and protocols. So it's a very broad reach. Really, you can plug and play these interfaces and connectors that are off the shelf, and they're ready to use without any extra development, testing, or integration on your part. So it makes the Pi system data collection process reliable and secure, as well as far-reaching. So I also mentioned other data sources besides SCADA are PLCs and DCS, manual data entry, and you can also enter data manually or, collect data from SQL databases and other relational databases, not just SQL. So one of these, let me pause this video for a second if it lets me. Then let me pause it 1 second. There you go. So one of these potential data sources is the AVEVA Historian. So as I mentioned earlier, with the 2023 system platform release and the recent OSI acquisition, AVEVA has sought to, provide better ways for Pi to integrate into the broader AVEVA software ecosystem, right? So the Historian to Pi replication is one of those integration methods. Another one is the AVEVA reports drivers that Brian mentioned, and I'll also be talking about the Omi Pi Vision app as well. So those are the main integration features of Pi that were released with 2023. But the new Historian to Pi replication feature can really help enable infrastructures where the AVEVA Historian gathers data on the SCADA network in a tier 1 configuration and shares data to the Pi server that sits on the enterprise network in a tier 2 configuration. You can currently do that with a tier 1 and tier 2 Historian, but with Pi, you can instead, leverage the tools of Pi and place it on your enterprise level to unlock more capabilities. And we'll explore those capabilities in a second. But this process basically strengthens your data security and data fidelity while, allowing you to segregate both systems. So that way you can have a member of your organization used the client tools like Pi Vision and Pi Data Link on the enterprise network while keeping them out of your SCADA network entirely. So let me go ahead and play this video here that shows the replication process. And this replication process that you see in this video, it might seem familiar to you, and that's because it's the same process as replicating from a tier 1 Historian to a tier 2 Historian, or from a Historian to our cloud AVEVA Insight product. So you can see here we're inside of the management console, which has been renamed. It's no longer the SMC. It has a new name now, but it's the same data, it's the same system platform management console, right? And so inside of here, what you can do is you can choose the data and you can actually rename it if you wanted to inside of this dialog box that you see here. So you can choose the destination tag name and decide whether to rename it under the source tag name column. And then what that'll do is it will replicate the data to the Pi system. And in a second here, the video will show. Now we're inside of Pi server, or sorry, Pi Vision, and you can actually search for those tags by entering the keyword M21. And the tags that you see down there under the attributes section are the historian tags that are being replicated from the AVEVA historian. So this is a little sneak preview into Pi Vision, which again, I'll spend some time demoing that. So don't worry if this seems overwhelming right now. So the second kind of layer to the workflow is the storing and contextualizing of the data. So this is achieved through the Pi server, which is kind of the heart of the Pi system. Gathering data is great, but if you can't, apply order to the chaos that is your data streams, how are you going to be able to draw any use from it? The Pi server is responsible for taking in all the data coming in from, the different sources using the data collection tools that we talked about and storing it for a long time at the highest fidelity possible. So this is the historian aspect of Pi. It's designed to be optimized for time-based data, so just like the AVEVA historian. And we have several enhancement capabilities and tools that can add value to the raw data that you have. And these include analytics, events and notifications, the asset framework, which we'll see in the next slide. And let me go ahead. I skipped ahead a little bit. Sorry, guys. There you go. So let's talk a little bit more about these data storage and enrichment tools. I think it's important to know, what these are, because these are the backend services that you can use to manage the historized data in the Pi server, which makes it really easy for you to then find that data and extract it using the client tools, Pi Vision, Pi Data Link. So Sarah brought this up earlier, right? How does Pi distinguish itself from the AVEVA historian? And I think these features that you see on this page are some of the main differentiating factors. It really depends which of the two products makes sense. I mean, for the most part, the historian is cheaper than Pi, but that's because Pi is a lot more rich and robust because it has these tools here, the data archive, the asset framework, asset analytics, so on and so forth. And for many customers, the historian can accomplish everything that they need, but for others, the added capabilities on this page are, extremely useful for this situation. And that's where Pi could be more appropriate. In general terms, though, I would say Pi is a data historian that, while it includes time series SCADA data, it also includes data beyond SCADA, right? Like financial data, for example. And so it's well suited to sit on the enterprise level, while the AVEVA historian is really meant to deal with SCADA level data only. So it's a little bit more limited compared to the breadth of Pi. And so as a result, I would say that the audience of Pi, like I said in the chat, is more varied and broader than the audience for the AVEVA historian, because the historian is more tailored towards operators, engineers, and technical folks like Sarah mentioned, and really the people that are working inside of the SCADA domain, right? So the first tool I wanted to talk about here is the data archive. The data archive is the real-time data storage layer that's used by on-premise Pi system deployments. So the Pi server will store the data in what's called Pi points or Pi tags with a timestamp and value. So it'll store it as time series data, just like the AVEVA historian. And data archive can actually store data with historical and future timestamps, and it can read up to 2 million different events per second, which is a pretty mind-boggling number, actually. So, you can write up to, I believe it's 200,000 or 300,000 events per second, which is pretty nuts. It's a very, as you can see with those numbers, right? It's a very high performance historian, one of the best on the market. And on top of data archive, we have the asset framework, and that's a data enrichment service that lets you create data structures and provide context to raw data streams, right? So what I mean by that is you can set up data hierarchies, like individual pumps that are aggregated into a pump station category, right? So you can have multiple layers of an onion, the top layer being a pump station, and the lowest and the layer below that being individual pumps in that pump station. And what you can do is you can attach some of the attributes associated with those individual pumps, like, you know, flow rate, pressure, etc., to the specific assets, the pumps, right? And then what that does is it makes it easy to create templates and copy them over. So in a lot of ways, it works like system platform, right? It's the same workflow where you can create templates and copy them as many times as you need to save time and make it more efficient. So in short, the asset framework really puts your data into context. It applies order to the chaos. That's really the point that I'm trying to drive home here that I keep repeating, right? Because you have all these different data streams, and sometimes it doesn't make sense if you just aggregate it, right? On top of aggregating the data streams, you need to organize it strategically to make it easy to extract using the data client tools like PyVision, PyDataLink. Whoops, sorry, I skipped ahead a little bit. And a few other tools that you have here are you can run calculations. And so the Pi server calculations are honestly some of the best in the market. And you can use multiple variables and give access to multiple users to a huge library of built-in functions. And if I have time, I'll dive into it when I show the Pi server. And these analytics can run in real time, and they save the results as an additional Pi tag, which you can then use inside of your Pi client tools. And you can also use these calculations to backfill for the entire history of your source data as well. I'm going a little bit slower than I wanted to here, so I'm just going to, there you also have event frames and notifications, and those are additional tools that let you bookmark important events and add descriptive context for further analysis and get notified on specific prescriptive alerts as well. And I'll talk about these when I demo the Pi server. And the last kind of final layer of the workflow is delivering the data to users. So this is where the Pi data visualization client tools like PyVision and PyDataLink come in. So you can use these tools to create dashboards, reports, and dynamic real-time displays that update every second. And one of the great things about these tools is that you can use them really anywhere. So you can use PyVision, for example, in any web browser or even a mobile device if you wanted to, as long as the web server authentication is set up correctly. So I'm almost done with this presentation. I'm going to jump into the demo, but the last thing I wanted to mention is the OMI app, the PyVision OMI app. And this is another one of these integration features that AVEVA released with 2023. So like the name entails, what you can do is use this PyVision OMI app to integrate existing PyVision dashboards onto system platform OMI screens. And when you use this app to embed PyVision onto an OMI pane, playing this video right now, you're gonna have some control over important parameters that give you really full control over the context of these displays. And that's one thing a lot of people underrate with this release is not only can you embed static displays, but you can actually inherit the context of those displays. So just as you can navigate between them inside of PyVision, you can actually do that inside of OMI as well. So you can inherit the way that they're contextualized inside of PyVision and navigate between the screens as they are inside of PyVision, but you can also adapt that to OMI and change the way that context is established. So really you have the freedom to inherit the PyVision workflow or create your own with OMI. Jump ahead here. And yeah, that's it for the presentation. So I don't have a lot of time left, so I want to jump into the demo of the Pi system here. So the first thing I'm going to do is show you guys what's called PyVision, which I've mentioned a couple times. I'm going to log in here. And PyVision is the first of the main two Pi visualization clients. And if you remember the 3 steps of the workflow, right? The last step of the workflow, after you've collected your data and organized it and enhanced it using the Pi Asset Framework and the other tools, is to deliver it. And PyVision is how you deliver that data. So let me go ahead.
Pierre, just as an FYI, you've got about 5 minutes left.
Okay, sounds good. I'll try to go quickly here. So this is PyVision. This is the home page. This is a demo environment that has a lot of these displays already created. So on the left side, you can see you can navigate between the displays that were created. You can favorite them, sort through the displays that you create, as well as the recent ones, and also organize them in folders. I'm going to select one of these displays to show you what is possible with Pi here. You can edit the time frame on the bottom, so you can choose the time frame of the data that is shown inside of this display. So this is like an 8-hour time frame, 1 day, 1 week, so on and so forth, and you can reset it so it displays. If I clicked on the now right here, you can see with the end time on the bottom right and the start time on the bottom left, it's doing data over 7 days up until now, right to this current second here. And if I want to create a new display, I just click on new display on the top right. And what I could do here is choose the different visualization options for the displays. So you have trends, you can do value displays, tables, so on and so forth. You have a pretty extensive list of options here. And then below, you can actually search your Pi system through that Pi asset framework, the hierarchy that we established using the Pi asset framework, and search for specific tags. So I'm going to search for example, I'm going to go inside this asset, water world, and below that are the attributes pertaining to that asset. And I'm going to select the trend option. And what I'm going to do is drag, for example, monthly water consumption, and that'll plot the monthly water consumption trend onto my display. So it's really easy, and it's really easy to pick up. It's intuitive, right? Just drag and drop to build out your KPIs here. You can also there's a graphic library, so you have different built-in shapes and symbols that you can use to build out your displays. For example, it looks like a pump right there. You also have some calculation options, and it's not as robust as the Pi server calculations, but you can do on-the-fly calculations using Pi Vision here. So for example, I'm going to create a sample calculation to show you guys how it works. What you need to do is select the tags that you want to use inside the calculation. And so what I'm going to do here is, because there's a tag that stores monthly water consumption, a different one that's monthly water consumption per capita, and one that's per population, I'm going to go ahead and multiply monthly water consumption per capita and population, and that should result in monthly water consumption. So if I go ahead and save that and drag the calculation over, you'll see that I produce the same result that the tag that stores monthly water consumption produces, right? So I was able to infer and calculate the values of this tag. The units are off, but that can be changed, right? You can have full control over how these trends are displayed. Another thing is the event frames. So you have what's called an event frame pane, which displays the events that occurred during the start and end time of the display. So what I mean by that is, inside of the asset framework, we can define events with a start and end time, and those can include downtime or specific alarms, and you define those inside the Pi asset inside of the Pi server, and Pi Vision will inherit those and let you plot data onto your screen that is based on that particular time frame. So the most useful aspect of this is, so what I'm going to do actually is I'm going to search for, well, actually, first what I'm going to do is I'm going to show you guys an event table. So this event table here, what it is it displays all the events that were, hold on a second. So what this event table does is it's just a list of all the active events, right? So you can just generate that easily, out of the box by clicking on Create Events Table. So these are all the events that are associated with the asset that I have selected here. But on top of that, I can see the list of events on the left side here as they populated because I searched for a particular asset. And what I could do is I could select one, pump stopped. Let's do daily water consumption, for example. If I drag that over, it will plot the daily water consumption values over the time frame of the event itself. So you can see that the event looks like it ran for about 8 hours here, from 5:22 a.m. to 1:22 p.m. And so it inherited that time frame and spit out the attributes that were defined and associated with that specific event, all inside of the Pi server, right? And then that way it's easy to very quickly create some displays where you can monitor the status of your relevant tags as they pertain to that particular event. So if I can go a little bit longer here, I would show the Pi server and the Pi data link as well, or open the floor to discussion, but I think I ran out of time. Do I have a few more minutes here? Maury, is that okay if I go a little bit over here?
Keep going. Yeah, if you got a few extra minutes, please keep going.
Okay, awesome. So I'm going to open up Pi server and Pi data link as well. But in the meantime, while I do that and I get it ready, does anyone have any questions about what I talked about so far or Pi Vision? Sarah, did I help historian and Pi?
I think we've been answering some of her questions in chat.
Awesome. Thank you.
Yeah, it's just been a lot of questions. The biggest thing is that we were using the Wonderware connector from the AVEVA historian connector to Pi, and that's been problematic. I think actually Mike has helped me out in the past getting that fixed when it's broken.
Which connector are you talking about? Sorry.
Yeah, so there was a connector made. In fact, we helped OSI create it, but it was very limited in what they could do with that connector because the APIs of replication weren't available publicly. And replication solves every problem that connector had. It really is the way to go in the future.
Gotcha. Sarah, I can get back to that, but I'm just going to wrap up here with and so this is what feeds the client tools like Pi Vision that I showed earlier. So the asset hierarchy that we saw inside of there that made it really easy for me to dive into the water world attributes, the tags that I selected, those are all defined inside of the Pi asset framework that you see in here. Or alternatively, if you have the AVEVA historian as a data source, that can also feed into your Pi Vision, right? So this right here is the Pi System Explorer, which is kind of the interface to the Pi server. And like I said, this is where you manage the Pi asset framework, and you can see it on the left side up here. You have your list of elements with the assets as well as the attributes that are associated with these assets here. And so this is how you organize your data archive, right, from different data sources. So here I can see that there's different templates, and I can actually create assets from templates. So I can create a new element, and then the templates that I define, I can go ahead and create an asset that's based off that template. So like I said, it's similar to System Platform, right? It makes it really efficient and saves you time when it comes to engineering your asset framework. So I went ahead and created this one. You can also perform calculations, right? Like I mentioned, under the analyses tool here, you can see on the right side, you have a long list of functions that are available to you. And these are the kind of robust calculations that come out of the box with Pi server that makes it the most powerful historian in the market. Because even if you don't have tags that store the value of different aspects of your system that you're looking for, you can use these calculations inside of Pi server to infer that data and calculate it, right? And then on top of that, you can also do it on the fly inside of Pi Vision, like I showed it earlier. But the calculations that you see inside of the Pi server right here are the most powerful and robust ones that you can do with Pi server. We also talked about event frames, which you can see on the bottom here. And this is where you can define the start and end time for specific events. And those are the ones that are going to be inherited inside of Pi Vision, like we saw earlier, to quickly draw inferences from the tags that are relevant to that particular event that you define inside of here. And last but not least, we have the second client tool, which is Pi Data Link. And what this is, it's just like, for those of you that have the AVEVA Historian client, right? It's just like the Excel add-in for AVEVA Historian, where it adds a add-in tool inside of your Excel environment that gives you some options here. It gives you access to these wizards that if I click on any one of them, it will populate, you know, a wizard configuration section on the right side where I can extract data from my data archive, my Pi server, and then perform calculations on it to develop these reports that you can see right here. So for example, if I want to click on a current value one, let's select longitude, for example, click OK, and it's going to output it in this cell. I'm going to click on OK, and then it generates the longitude value of that particular attribute. So yeah, it's 127. So that was just a quick overview. I'm running out of time. So with that, I'm going to wrap up this presentation. Thanks everyone for listening.